Hello everyone, today in this video we'll be discussing the module 4 of ADA. So in this module we have the following topics and the questions in the exams comes mostly from these topics only. Okay, so if you watch this video till the end, easily you can score more than 80% marks. Don't miss any of these topics. I'll be telling you what all you need to remember from these topics with the algorithm and an example problem. Okay, so before starting, please do like and subscribe. It helps me make more videos like this. Without wasting more time, let's get started. The first thing you need to know in this module is the knapsack problem. Okay, it's an easy module. I'll be telling you what each of these topics are. Okay, knapsack problem means suppose you have a bag. Okay, you have a bag, and in that bag you can store 20 kg. Okay, now next thing is you have 5 items. Okay, you have 5 items, and each of these items has a weight. For example, 1 kg, 2 kg, 4 kg, 3.5 kg, 2.5 kg. Some weights are there, and each of this item has a cost, like it is $10, $20, $30, like that. Okay, different weights. So you have 5 items which has their own weight and it has the value as well. Okay, and you have a bag also, and in that bag you can have at most 20 kg. Now you live in city A and you have to go to city B. Okay, now which you have to carry which items you have to carry from city A to city B, so that in the city B if you go and sell you will get most profit. So items are present, you have to select those items which will be fitting in the bag, because I can't exceed 20 kg. It will be fitting in the bag, and the if I sell all those I'll get the highest profit. Okay, that I have to choose. So the problem is to choose items such that the total weight does not exceed the limit of the bag and the value is maximum, the profit value. Okay, so let's take an example. There are 4 items given here: item 1, 2, 3 and 4. The weights are given: 2, 1, 3 and 2. The values for each of these is given, and it's given that the maximum capacity is 5. So I have to choose few items from this. I cannot choose all because it exceeds 5. I have to choose those items such that it will be putting inside the bag and the value of that addition will be highest. Okay, I have to choose those items. So we will be solving this using dynamic programming. In the previous one module we have solved it using some other method, right, greedy algorithm, but now we will be solving it using dynamic programming. Okay, in exam also they will be giving you just this much. Okay, this thing will be given and you have to make this table and find out the answer. So in this case answer will be 37. How we will do that? Let's see. Now I will be nothing but the number of items. Here number of items are 4. You will start from 0 and write till 1, 2, 3, 4. The number of items which are present here will be writing here, and starting will be 0. Okay, 0 we have to write and put all as zeros. Okay, now capacity means how much is the capacity given? 5. So we'll be writing 0, 1, 2, 3, 4, 5. Done. Now if it is 0 items, if it is 0 number of items, what will be the capacity? It will be 0 only. Okay, even if the capacity is 1, 2, 3, 4, 5, how many items I am able to carry? 0 items I am able to carry. And if I am able to carry 0 items, my profit will be 0. If I am able to carry 1 item but I have no items present, it will be 0. If I can carry a capacity of 2 but I have no items, it will be 0. So it will be 0 till here. Got the point? Next is 1 item. We'll be considering 1 item now. Okay, so first item we'll consider which has the weight 2 and value as 12. Now I have 1 item. Okay, and the capacity is 0. If I see the capacity 0, can I store this item with capacity 0? No, I need minimum capacity of 2, right? So this will be 0 here. And capacity 1, it cannot be stored. Capacity 2, yes, it can be stored, right? Capacity 2, this can be stored. And how much profit I'll get by storing that and selling it later? 12. So I'll be writing here 12. Okay, and capacity 3 also, since I have only 1 item, I can store this one. I'll store it here. Next, 4 also capacity same only, 5 also capacity same only. So 2 will be occupied, to the 2 capacity will be occupied in the 5, and 3 will be remaining empty. Okay, now since empty is there, we can fill another item. So we'll write the second row. If we choose 2 items, okay, first and second item, if we choose, okay, if I choose first and second item, 2 plus 1, 3. If I have minimum value of 3 capacity, I can store both of them and I'll get the profit 22. But if I have the capacity 2, I can store this one, right? Because it gives more profit. If I have capacity 1, I can store this one because it's capacity 10. If I have capacity 0, none of them will be stored. So that's what we'll do for the 2 items. Capacity 0, I'll not get anything. Capacity 1, I'll store just this item and earn 10. And if it is 2 capacity, I'll store only this and get 12. If it is 3 capacity, I can store both, which is 10 plus 12, 22. This also is 22, this also is 22. That is for 2 items. Now 3 items we'll consider. Okay. Now 3 items if we consider, we cannot store all 3 items because 2 plus 1 plus 3 is 6. So we have to choose 2 among them. Okay, I can choose only 2 among them. Which 2 I have to choose? Now, if the capacity is 0, I'll be having nothing. If the capacity is 1, among these 3, if capacity is 1, what I can store? Only this. So I'll store it here. If capacity is 2, okay, can I store this? No. Can I store this? Yes, I can store with the capacity 2, but it is lesser cost, right? With 2 I can have another cost which is 12, which is greater. So I'll take as 12. If capacity is 3, I can store this one, or I can store these two. I have two options. If capacity is 3, I can store either this one or these two. If I store these two, I'll get 22. If I store only this, I'll get 20. Obviously, I'll choose 22. So for 3 items, 22. Now for 4, capacity 4. For capacity 4, can I choose all these 3? No, I can't. So can I choose this and this? Yes, I can choose. If I choose this and this, my cost will be total as 30. That is the highest cost. If we do any other combination, 3 plus 2 I can't do, and 1 plus 3 I have done, which I have got 30. That is the highest. I can do 2 plus 1, but it will be 3 capacity only. I have 4 capacities, so why to waste one capacity? And the cost will also be lesser, 22. So the best combination in 3 is 3 plus 1, and this will be 30. So if I have capacity 4, I can use these 2 items, and I'll write 30 here. Now if I have capacity 5, 5 means I can store 2 and 3, right? Because this will give higher cost. 20 plus 12 is 32. So I'll store 32. Now capacity 4, I mean the 4 items can be taken. If we take all 4 items into consideration, and we'll select only those items which has the highest ones. Okay, so if it is 0 capacity is 0, 1 capacity, this is the highest, 2 capacity, which will be the highest. If there is 2 capacity, I can store 2 items, and 2 items I have here as 15, and 2 item here I have as 12. So capacity 2, I can choose in between these two. This is greater, so I'll choose 15. Now capacity 3, if capacity is 3, I can choose this one, or I can choose the combination of these two, or I can choose the combination of this and this, right? This one, this also I can choose. So if we consider all 3 possibilities, this is the highest, which is 25. So I'll be writing 25. Next, capacity 4. Capacity 4 means I can choose this one and this one, or I can choose this one and this one. So if we choose these two, what is the cost? It is 25, I mean 27. And if I choose these two, that will also be 4, it will be 30. So I'll choose 30 and write here. Now capacity is 5. 5 means I can choose these, this and this, right? 5 will be successful then. So it will be 15, 25, 35, 36, 37. And other possibilities also include 3 plus 2 is 5, right? But it will be 25. And 3 plus 2, this one, the above one, 3 plus 2 is 5, but it will be 22, right? And I can choose 1 also, 1 among 3, but it will again cost 4 only. So the best combination we have to choose. So best combination in this case will be this I'll choose with 2 capacity, this I'll choose with 2 capacity, and this one I'll choose with 1 capacity. So total capacity is 5 and the total profit will be 37. So this is the highest value which I can achieve with 5 capacity, and this is the maximum profit. So this is how the knapsack works using dynamic programming. Okay, now the memory functions also exist. Memory function means, since we know that if there is 1 capacity, it will always be these values only. It will be 10. So we are not concerned about 10, right? Because 10 is of no value. 10 cannot be the highest. So we will write 0 0 till here, and after this we will not write it. Okay, and only in those cases which we think that it can exceed, that places only will be continuing to write. Okay, this is just a understanding concept. Okay, exam they will not ask memory function. The first thing which I explained, you have to do in that way. Okay, but this is more efficient because we are not calculating redundantly the same values as previously we used to do. Okay, so this is the difference. And this was about the knapsack problem. This much you need to know, the algorithm as well as the problem. Okay, they can give you the problem of sample weights, values and profits, and you have to calculate an answer in this form like the previous one. You have to finally get a table in this form, and the final answer will be 37. I mean, whatever the answer you get, that will be the final answer. It will be at the end here. Okay, that was about the knapsack problem. The next one is Warshall's algorithm. Okay, so basically in Warshall's algorithm, what we do is we have a graph like this. Okay, in this graph, we have to find out which vertices to which vertices we can go. Okay, if you observe carefully, A to B I can go, right? And B to D I can go, and D to A I can go, and D to C I can go. This is what I can observe within the graph. But if you observe a little bit more carefully, from A I can go to D also. How? Through B, right? But it is not direct edge, it has an indirect edge. Okay, So Warshall's algorithm finds all those indirect edges. From A to C, can I go or not? If I want to check it, I'll check this value A to C. There is a 1. That means I can go. This is the final answer. Warshall's algorithm will generate this. That is called as transitive closure. But if I observe just the adjacency matrix, is there a direct line from here? No, it's not there. So if we check A to C, there is nothing present. Got the point? I can go from A to C through B and D, and that is also included here. Like that, things you will find that is called as Warshall's algorithm. So the algorithm calculates if there is any path from one vertex to another vertex using transitive vertex. Okay, and the definition also they can ask in exam: define transitive closure. So transitive closure of a directed graph which has a direction that graph is called directed graph in n vertices. N vertices are there, can be defined as n cross n Boolean matrix. There is n cross n Boolean matrix T of ij, in which element I and the jth column, ith row in the jth column is 1 if there exists a non-trivial path, directed path of a positive length from ith vertex to jth vertex, otherwise T of ij is equal to 0. So we are calculating this matrix if there is a path from A to D, whether indirect or direct. If we have a path, we will be writing as 1, else it will be 0. That is called as transitive closure. Okay, now let's take an example. In this example, basically what we'll be actually doing is we'll be considering one row and one column at a time. So we'll be considering the first row first column at a time, second row second column, third row third column, fourth row fourth column, fifth row fifth column, nth row nth column, like that. Okay, and whenever we consider the nth row and nth column, whatever row and column, at that case if you have 1 and 1 present at the same place, I and j, like this, if we get 1 and 1 in the matrix table, we have to make this 0 also as 1. Got the point? Let's discuss an example, you will be able to understand. Okay, so this is an example. So basically what we'll be doing here. Okay, see, listen carefully. Okay, this is the question which they will be giving. Okay, this is the graph which they will be giving, and they will be telling you to calculate the transitive closure, the final which we have here, the above one which I showed you. Okay, transitive closure is this one. You have to find out this one. This will be the final answer. How can you find out that? Using a graph, by using Warshall algorithm. Okay, basically what you have to do is first consider this row and this column. I mean this row and this column. In this row and this column, where all 1 you can find. 1 I can find here, 1 I can find here. So if we join both of these, this is the place where I'm getting. So this point I'll make it as 1. Got the point? You have to do like that. Wherever you find 1, mark it. Wherever you find 1 here, mark it. And wherever these two meet, make it as 1. That is the first iteration's answer. Second iteration, again, in this and this, how many 1 you can find? I can find a 1 here, I can find a 1 here, and I can find a 1 here. Now, take 2 at a time. In this column I will take this first, and this row has this one. So these two if we combine, we'll be getting this one, so it will be made as 1 here. Okay, and this one is here present and this one is present, so if we combine these two, we'll get this place here. So this also will be making it as 1. Got the point? These two will be becoming 1 here. Next iteration, here any 1 you can find? Yes. Here any 1 you can find? No. If there is any 1 here but there is no 1 here, we can't compare it with something, right? This has to be compared with 1 present here. We cannot do that, so therefore it will not be nothing will be changed. Okay, now after that we'll consider the last row. In last row, how many 1 you can see? This one and this one. And how many 1 you can see? All of these are 1s, so there will be a lot of combinations. Okay, we'll consider one by one. We'll start from this one and this one. If we combine both, what answer I'm getting here, make it as 1. Okay, so this will become 1. Now after that, this one with this. Okay, this one with this, if we do, this will also become 1, right? So this will also become 1 here. Next, this one is there, and this one, the same row we will not consider. Okay, so already it is 1. Why we should consider the same row? You have to consider with the different one. Okay, next, this one is done. This one with these two ones, that means these two should become 1, right? That's what we'll be getting if we do it individually also. So these two will become 1. Next, for this one also, these two will become 1, right? So these two became 1, and that's it. We reach the end here. So the final answer will be this one will be the transitive closure. Okay, and that's the Warshall's algorithm. Okay. Next one we have the Floyd's algorithm. Okay, let's have a look. What is a Floyd? What is the Floyd's algorithm? So the previous thing, everything is same except that here values will be greater than 1. That's it. This is the algorithm, and if you see the problem here, you can see that there is direction also. Previously, was there any direction? Yes, direction was there, so there is no much difference. So you observe carefully. Now A, B, C, and D is here. Now, how do we make this graph? That also I'll explain. A, B, C, D is present. A, B, C, D is present. Now, from A to B, is there any edge direct which you can see? Is there any edge from A to B? No, it's not there. So 0. Okay. And is there any edge from A to D? No, there is no edge. So A to D will also be 0. Sorry, infinity. Okay. The A to A is 0 because there is no self loop. Okay, so it will be 0. And A to B, there is no edge, so it is infinity. A to C, there is an edge, it is 3, so we will be writing 3. A to D, there is no direct edge, so it will be infinity. So whichever does not have a direct edge, that we will be writing infinity. Like that we'll be doing for all. We'll check from B to A, B to D, B to C. Okay, B to A it is 2, B to B will be 0, like the diagonal elements will be 0 here, as in the previous case also. B to C. B to C we do not have a direct edge, so it will be infinity. B to D also we do not have a direct edge, so it will be infinity. So like that we'll fill for C and D as well. Next what we'll do, consider this one and this one. And consider which are the elements which are having the numbers. Okay, the numbers which are there. The numbers are present at 2 and 6, and the number is present at 3. Now, consider one at a time. 2 and 3. 2 plus 3 is 5. So this infinity will be converted to 5. Next, 6 and 3. 6 and 3 means 9. This one will be converted to 9. Okay. Next, any other number? Any other number? No. Done. Take the second row, second column. So second column and second row. How many numbers? These two are numbers. How many numbers? This number. So this one will be 1 and this one will be another. 2 plus 7 is 9. This will become 9. And 7 plus 5 is 12. This will become 12. So just a second. So here it is 7 and here it is 5. So 7 plus 5 is 12. This should become 12. But still it is 0. Why? Because we'll compare 12 is greater or 0 is greater. 12 is greater. So why we need greater costs? We need lesser costs. Okay, so 0 is already having lesser cost. We'll keep it as 0. Got the point? What is the logic behind it is, see which one we are considering. We are considering from C to C. Okay, the C to C, there it will be 0. We cannot take it as 7 plus 5, 12. Okay, why? Because C already it is there and its self loop will be 0. Okay, we need not update the self loops. Okay, it will always be 0. But if you observe carefully here, C, I can reach C again by traveling like this. Okay, 7 plus 2 plus 3. Again I'll reach C with the cost 12. Why do I need to again reach C while I'm already present at C? So that doesn't make any sense. So self loop, everything will be 0 and we'll compare. In the previous ones where we are replacing, why? Because we'll compare here also. 2 and 7 is 9. 2 plus 7 is 9. We are comparing 9 with infinity. Infinity is greater. 9 is smaller. We need smaller numbers. So we will be writing it a smaller number here. We are comparing 7 plus 5 is 12. 12 and 0. Which is greater? 12 is greater. We need smaller number. Keep it as 0 only. Okay. Done. Now all the numbers are done in the second row and second column. Now third column and third row. How many numbers are there? 3, 5, 9 and 9, 7, 1. So there are many numbers. We'll be taking each one by one. And we'll be comparing. Now let's take 9 and 3. Okay, 9 will be comparing with all these elements. So 9 plus 3 is 12, but already is 0. We need not disturb it. 9 plus 5 is 14. 14 will not disturb it again. Right? 14 and 2. 2 is already smaller. 9 and 9 is 18, but 6 is already smaller. We will not disturb it. Next, 7 and 3 is 10. So this will be replaced with 10. 7 plus 5 is 12. This is 0. Will not disturb it. 7 plus 9 is 16. This is infinity. We'll be updating it as 16. Now, next, 1. 1 with 3 is 4. So we'll be writing here as 4. 1 plus 5 is 6. Infinity is greater than 6. So we'll be writing here 6. We need smaller numbers. 9 plus 1 is 10. But here is 0. 0 is lesser. So we'll keep it as 0 only. Last row, again the same thing. 16, 6 and 4 is 10. This is smaller. Let's keep it as same. 6 and 6 is 12. This is smaller. 6 and 1 is 7. This is 9. So this will be replaced with 7. See, 6 plus 1, 7 will be replacing. Next, 16 plus 4, it's greater than 10. 16 plus 6, it's greater than 0. And 16 plus 1, 17 is greater than 7. So will not make any change. Same thing goes with 9, 4, 9, 6 and 9, 1 also. So all of the remaining are same and this is the final answer. The next algorithm is the Prim's algorithm. So they have given endpoints. Connect them in the cheapest way possible. Okay, so we need to connect the endpoints such that the connection between the endpoints, whatever is the path distance will be there, that distance will be the cheapest. Suppose I have 4 points, and how can I connect them? I can connect in many ways, like this, like this, like this, like this. I can connect in many ways, but only those way I have to select such that if I connect it in this way, it will be cheapest. or if I connect it in this way, it will be cheapest. Like that, I have to see which connection will make it as cheapest. So that is called as Prim's algorithm. They can ask you the definition of spanning tree. In the previous exam paper, they have asked the definition of spanning tree is an undirected connection graph that is connected in acyclic subgraph. Acyclic graph means what? The graph which does not have cycle. This is acyclic, and this is cyclic because it has a cycle in it. Okay, and that contains all vertices of the graph, so all the vertices should be connected at the end. Okay, none of the vertices should remain as not connected. Okay, all the vertices should be connected. And if such a graph has weights assigned to its edges, minimum spanning tree is the spanning tree of the smallest weight, where the weight of the tree is defined as sum of weight on all edges. Now we have connected few edges here. If we calculate the weight of all these edges, it should be the smallest, the way in which we connect. Okay, that is the minimum spanning tree. Okay, now this is the algorithm, and what we basically do here is, if this is the graph given, here multiple connections are made. See, for F, the connection is made from B, from C, from A, from E, from D. But F only requires one connection such that all the vertices will be connected. Suppose that I remove these five. I removed these five. Okay, only this one is remaining. Okay, just imagine F is only connected with this and not with this. Still, I can access F by using all of this. How? If I start from A, I'll go to B, C, D, and I can go to F. So it's not necessary that F will be connected with C separately, because if in one way I can able to connect it or reach it, I'll remove all the other ways which have more costs. Okay, we'll select the cheapest cost. So basically, start from any of the vertices. In this case, I'm starting from A. So A I'll be taking, and observe A is connected to which all vertices. It's connected to 3 via B. Okay, so it's connected to B and A comma 3 means from A to B the cost is 3. Okay, and is A connected to C? A is not connected to C directly. See, A is not connected to C, so it will be A is not connected and it will be infinity. And what about D? Is A connected to D? It's not connected, so minus infinity. Is A connected to E? A is connected to E via the cost 6, and A is connected to F via the costs 5. Okay, now what I am going to do is, the remaining vertices I have taken, and one vertices I'll be taking into consideration. Okay, you can take whichever vertices you want. So B, A comma 3 I'll be taking here, and then I'll be observing B is connected to which all vertices. It's connected to C via 1 comma C, right? So now what will happen is, this thing will be getting updated. Okay, this thing will be getting updated. This will be updated by, here it is infinity, but through B I'm getting the cost 1 only. So I'll be updating infinity with 1, and this one I'll be replacing with B, because from B I have a connection and I've taken into consideration B. So from B I have to take it, or take whatever I have to take, the distance. So distance will be calculated from B now. So B to C, it is B comma I mean 1 distance, and C and D is okay, B and D is not connected, so it will be infinity, and B and E, it's also not connected, but the previous cost we have from A, which is 6, will retain it. If it is having a lesser path, then we will update. Like this one has higher cost, which is infinity, this one we have lower cost, so we updated it. But here it is lesser only, and from B we are going to get as infinity, so we'll keep it as lesser only. Okay, and F, we'll check F. Is B going to F with a smaller cost, or A is going with a smaller cost? B is going with a smaller cost, so FA5 will be updated with FB4. F, I am able to reach through B with cost 4, so this will be overridden by this one. Now we have selected B, so this one will be highlighted if you observe carefully. Then from B I will be selecting one of them. Okay, usually I will select the first whichever I get, so it is C. So it will be having a bold highlight here also. Next, the same thing we'll do with C also. From C, how many connections I have? I have a connection with F, I have a connection with D, and I have a connection with F also. Okay, C, I mean D, E, F. Okay, this is, I have a connection with F, and I have a connection with D. I have a connection with E, but not directly from the previous one I have taken. Okay, so since C is taken, what are the remaining vertices? D, E, and F, and the updated cost will be done here as we did previously. Again, we'll be selecting one of them. You can select any of them. We'll select F here. So if we select F, again from F we'll calculate whichever vertices are not visited, which is D is not visited and E is not visited. So D and E, I'll be calculating how much it costs from F5 and 2. So I'll be writing 5 and 2, and after that we'll take any of them. We'll take E in this case. So from E I can reach to D. I can reach to D via 8 cost, but previous I had from F I can reach via 2 cost, right? So from F I can reach to the C. From E to F I can reach via 2 cost. Got it? And from F to D I can reach via 5 cost. Got it? So total cost will be 2 and 5, but we'll not consider it like that. We have to just see from the previous values. Okay, see, previously from F, okay, forget everything whatever I told. From F, what is the distance to D? From F, the distance to D is 5, and distance to E, it is 2. So I took E. E I have taken into consideration. Only remaining vertex is D, F5. Now from E I can go to D with 8 cost, but previously I had gone through F with 5 only, right? So 5 I will compare with 8, whichever is smaller that I will take. So this is smaller, so I'll not write 8 here. I'll keep as previous ones only, which is 5. Why? Because 5 is smaller, so I'll be keeping it as such, and that one will be taken into consideration. Okay, means DF5, that one will be made as bold. So in this way you arrive at a conclusion where you have the bold points, which means that is the shortest distance which we have to reach from one node to other node. If you observe, from C to F, if I want to reach, okay, C to F, if I want to reach, how I will reach? 4 plus 1, that is the shortest path. If you observe carefully, if I go in this path, it is more. Okay, C to F I can go 4 also, but here if we consider all the total cost, okay, what will be the total cost? 3 plus 4, 7, 7 plus 1, 8, 8 plus 2 is 10, 10 plus 5 is 15. We have total cost is 15. But if I don't take this path and I take this path directly, this will also be considered. So if this is considered, it will be added up. 15 plus 4, it will be 19, right? So it will exceed the cost. So I'll use this only because this is connecting to C and F also, and this path we have got via tracing the algorithm. So logically this is the smallest values which I have, 15. It will take $15 to reach all the nodes, and that is my final answer. Okay, this is how you solve the Kruskal algorithm, the Prim's algorithm. Okay, now the Kruskal algorithm is also very similar to the previous one, where we will construct a graph which will connect all the nodes. But here what we do in a different way. So firstly you need to sort the weight nodes in ascending order, means small to big, increasing order you have to sort it. Okay, and choose the nodes which are connected to a graph, how it is formed. Okay, so this is the algorithm, and in this case what you will be doing is you will be arranging the nodes according to increasing order. So one is smallest, BC, right? So BC I'll be writing, and one is smallest. Then 2 cost, FE. So FE or EF, whatever. So I'll be writing 2 here. Next is AB 3, and which is 4. 4 is BF and CF. So BF CF is 4, and AF is 5. FD is 5. So both I'll be writing here. And this is 6. This is 8. That I'll be writing 6 and 8. Okay, this is also 6. So we have got the sorted list. Okay. Now what we need to do is we'll consider from here BC. Okay, BC we have taken it as 1. Okay, next we will take as EF. Okay, EF will take it as 2. Done. Now we will take as AB. Now in the same way we have to go. Okay, AB is also taken, and next we will take as BF. When you take BF, if you observe carefully, I have connected how many vertices? A is connected, B is connected, F is connected, C is connected, and E is connected. Only remaining one is D. How do we connect D? Now after connecting the BF value, to connect to the D, which one I can use? Among this, to connect to D, which one I can use? Obviously I have to use this one to connect to D from F. So it will be costing 5, and that's the least cost. If I go from here, it will be 6. If I go from here, it will be 8. If I go from here, it is 5. This is the least one. So bold point will be made from here, and this is how you solve the spanning tree problem using the Kruskal algorithm. Next is the Dijkstra algorithm. So this one, what we do is a graph is given, okay, and we have to calculate the shortest path from one vertex to all vertices. Okay, in previous one we used to calculate distance from all node to all node, but here one source node will be there. From this I want to reach to all the other nodes. What will be the cost to reach? That is called as Dijkstra's algorithm, and this is the algorithm, and here is the picture. So basically here what you need to do, you have to take one source vertex. They'll be specifying in the question which is the source vertex. Okay, so whichever they specify, suppose they specify as A as source node, you'll take it as A. Now I have to find the distance, shortest distance from A to B, A to D, A to C, A to E. Okay, that is the that is where we'll be applying the Dijkstra's algorithm. Let's see how it works. In order to check how it works, what you have to do is they'll be giving you a source vertex. Okay, source means from A. Suppose I have to calculate. So what I'll do is I'll take A. Okay, and to reach A, I don't need any cost, and without any vertices, I'm reaching A. So this will be writing as dash and 0 because the cost is 0. From A to reach it is 0. And to reach B, what is my cost? To reach B from A to B, it is 3. Okay, and to reach C I cannot reach C, so it will be dash and infinite. And to reach D I can reach A to D via 7. Okay, it's given 7. and E I cannot reach, so it will be infinity. Done. I'll have to choose a least cost. Least cost is 3, so I'll consider 3. So since I've considered 3, I'll make this as bold. Done. Now again from B I can go to C, I can go to D. Okay, so D and C, E I cannot go, so it will be still infinity. E I cannot go, so C and D have to make some changes. So to reach C, what will be my cost? 4, and to reach D, what will be my cost? It will be 2. Okay, so to reach C, it is 4 now. Okay, so since it is 4 and previously it was 3. Okay, from here it was 3 and this is 4, so I'll be writing B comma 3 plus 4, which is 7. So via B I can reach to C via the total cost 7 from the source node. Okay, like that only for D. For D I can reach via 7 directly, or I can reach to 3 plus 2. So I'll be considering this one 3 plus 2. So I'll be taking this path and I'll be reaching here. Done. And this will be 5. Okay, 3 plus 2 is 5. So DB is 5, and this one is already from the previous one, which is 7, B comma 7, and E. Now I'm present in D. Okay, I can reach E. Okay, I can reach E via direct path, which is 4. Okay, but what was my previous cost? My previous cost to reach D was 3 plus 2, which is 5. So 5 plus 4, it is E, which is equal to 7. I mean 5 plus 4 is 9. Okay, so this one will be 5 plus 4, 9. Okay, now this 3 plus 4, how I had got? This 3 plus 4 I had got via 3 plus 4. So this is the thing which I'll be considering now. Okay, see, if you consider from D, okay, D I can go via 5. Okay, so if you consider the whole cost, A, like this it will come 5, 3 plus 2 5, 5 plus 5 10. Or I can go directly to C via B, which is 3 plus 4 7. Since this is shorter, we'll be choosing this path and not this path for C. So this one will be highlighted. Okay, this one will be highlighted. Okay, got the point. Now since this is highlighted, what we'll be doing, we have two costs, 9 and 7. So 9 will be keeping it as such and we'll be highlighting that also, but here we have 7, so we'll be taking as 7 here from C. Now if we consider from C, we have total cost 7 and 6. 7 plus 6 is 13. 13 is greater or 9 is greater? 13 is greater, so this is a greater cost. So I'll be keeping it as such only, the previous cost which was giving me 9, and that will be my final answer. This is the final answer you need to make for Dijkstra's algorithm. Now from A to B, what is the cost? 3. From A to C, what is the cost? It is 7. What is the cost from A to D? It is 5. Like this, it is 5. What is the cost from A to E? A to E, it is 5 plus 4, which is 9. And these values are the shortest values, okay, which you have in the graph. If you take any other path, it will be more than these values. This is how the Dijkstra's algorithm work. In the exam, they'll be giving you a graph like this, and the source node they'll be mentioning, which is a source node, and you have to construct a graph like this and write these steps to find out the final answer. And at the end, you need to write this. If you don't write, you will be losing some marks. Okay, why? Because this one is just a graph, and final answer is this. Finally, we have to write what is the values for each from the source to the destination. Okay, very important. If you don't write this, simply you will be losing 2 to 3 marks. Okay. The last topic is the Huffman trees and codes. Okay, so the steps are given here and go through it. Okay, but I'll be explaining you what you actually need to do. Okay, such that if you observe the if you understand what I'm telling, if you listen carefully, you'll be able to write these steps in your own words, and for that also you'll be getting marks. Okay, so the tree constructed using the above algorithm is called Huffman tree, and in the described manner, if you do it, means the way in which it works, if you do it in that way, it will be called as Huffman code. What is the Huffman code? I will be telling you. Okay. Now see, 5 letters are given: A, B, C, D, and underscore. Okay, A, B, C, D, and underscore. Now, with the following occurrence of frequencies, our text is made up of these symbols. Now, they will be giving you symbols and the frequencies. Okay, this is what they'll be giving in the question, and they'll be asking you to find out the Huffman code, Huffman tree, or they will be giving you a combination of letters and finding out to encode it, or they'll be giving you some numbers and you'll be should be able to calculate the decoding, which means the letters back. Okay, all these things I'll discuss. First, what you have to do, arrange this in the ascending order. Okay, ascending means small to big. Okay, if you arrange from small to big, 0.1 comes first, which is B, then comes 0.15, which is underscore, then comes 0.2, which is C, then comes 0.2, which is D, then at last comes A, which is 0.35. Choose the least 2. Least 2 is these two. If you add up these two, what will be the answer? It is 0.25, which is greater than this and greater than this, right? So we'll be placing it here, 0.25, which is greater than these two. Now the smallest, these two are will be the smallest, and 0.35 will remain here only. These two are the smallest ones. We'll be mixing it. If when we mix these two, we'll be getting 0.4, and 0.4 is greater than this and greater than this as well. So we'll keep it at the end. and the smallest two will be 0.25 and 0.35. Again, we'll be combining these two. Will combine when we combine 0.25 and 0.35, it will be 0.6, and when we do 0.6 and 0.4, 0.4 is smaller, so we'll keep smaller here. 0.6 is greater, we'll keep it here. Next, 0.4 and 0.6 will be combining, it will become 1, and it will be forming a graph. After we have found the graph, 1 will be here, then 0.4 here from here, and it will be 0.2, 0.2, and C and D, which is corresponding to here. And here it will be the 6 values, which is there 0.25, 0.35, 0.1, 0.15. Like that we'll be putting. And all the left branches will be marking as zeros, and all the right branches which you have will be marking it as 1. Okay, 1, 1. This is left branch, this is left branch, like that. Okay, from each node's perspective, left branch is 0, right branch is 1. Okay, that will be applicable for all the nodes present here. After you have done that, you have to calculate the number code for each letter. For suppose for C, what is the number code? It is 0, 0. You have to go like this. Okay, 0, 0. Okay, so for C it will be 0, 0, and for D it will be what? 0, 1. Right? For D it will be 0. And from the top you have to go. For B, what it will be? 1, 0, 0. For B it will be 1, 0, 0. For underscore it will be what? 1, 0, 1. Right? Underscore it will be 1, 0, 1. For A it will be what? 1, 1. So A will be 1, 1. Now you have got the symbol and frequency and code word. Now if I ask you, what is the code word for ABC? For ABC, what is the code word? For A it is 1, 1, so I'll be writing 1, 1. B it is 1, 0, 0, and C it is 0, 0. So this is my code word for ABC. Got it? And if they give you the numbers, for example, if they give you 0, 0, 0, 1, what is the letters equivalent? 0, 0 is C, 0, 1 is D. So you can easily write CD. Two type of question can be asked: encoding and decoding part. Okay, and I have to explain this one, the algorithm, as well as the tree you have to make, and you have to make this final table. Okay, so that you can expect full marks. That's all from the module 4. If you have found this video helpful, please like and subscribe. It helps make more videos like this, and thank you so much for watching. I'll see you in the next.